Okay, so we're going to get started. Sorry about last week. It is what it is. It happens to the best of us. I think, like I said, I think it was the first time in 5 years I've missed class. So, it is, it happened. Anyway, so we're going to pretend like last week didn't even happen. See, isn't that the great power of being in charge? You can decide to declare that, right? So you guys got a week off. Good for you. It was spring break early or something, right? At least from this class. So today we're going to pick up where we left off, if you can remember back to way back when we left off. Because of that, I'm going to refresh everybody a bit on what exactly we're doing. You got two handouts today. You got your assignment 202 handout, which is about the next assignment, which I'll talk about in just a second. And we got the exercise 212 handout. Today's exercise, essentially, we're starting to get ready to do the assignment 202. So the work that you're doing today kind of works toward getting this accomplished. In terms of assignment 202, I started passing around a few of these topos. You're going to be building one of these topos. Here, you guys can have this one. These are previous semester topos that I'm passing around. The goal here is for you guys to obviously learn how to manipulate surfaces in Rhino, but also to figure out how do you actually construct a physical model out of something that you made in Rhino. So for this assignment, for 202, we're going to be slicing it up and gluing it together. So you will have a few little costs associated with doing this assignment. Good news is it's all done on the laser cutter, so that's good. Other than you have to glue it together. Next assignment on 203, as part of that one, we'll do some 3D printing. So you'll have exposure to both methods of getting 3D models out of the computer, both of which I think are important. And so we're gonna go through and do that. As far as this goes, the strategy here could I slice up the piece of topo and then glue 20 different sheets together to make this? Sure, and it would be a big solid brick, but it uses a lot of cardboard, and it costs a lot because you're using a lot of cardboard and you're having to glue it all together. The method that I'm going to show you makes this hollow. So obviously the back is hollow, and it uses two or fewer sheets of cardboard to do it. So it's pretty economical to do it. If you learn this method well, you could end up doing this out of plywood. You could do it out of any material that you wanted to create a piece of topo. And learning to do this quickly and efficiently is really critical for your career down the road. Here at DVC, we love giving you those flat sites. I've always lamented the flat sites that you guys always get for all your projects and whatever. As soon as you move on to Berkeley or Cal Poly, they're going to give you sites like this that have tons of topo, and you'll be making topos all the time to put your little models on. And so if you get fast at doing this, it's no big deal. If you're slow at doing it, it is a big deal. So we're going to try to get you all fast at doing this. Start to finish, if I were to make this of a brand new piece, personally, if I were to make it, I could probably do it I could definitely do it in under 2 hours. I might be able to get it under an hour. And obviously I have a fluency level in Rhino that you guys don't have yet, but it's not that long. Okay? So I'm going to walk you through this whole process today. We will stop about 3/4 of the way through because you'll just be overwhelmed, and then we'll pick up where we left off. So I will repeat myself today as if I didn't do anything last class. So it'll be a fresh start. And then when I do it again on Wednesday, I will start as if I did nothing. So I'll keep building on it. So you'll see me do the same thing a couple times. So this is what is due. There's actually two specific due dates relating to this. The first one, and you know what? I made these copies before I was gone for a week. So I might have to double check the due dates on these to make sure that they're matching up correctly. Anyway, there is a due date for your digital file, the laser cut file, which kind of forces you to get that part of it done. And then a couple weeks later, you'll actually turn in the full cardboard model. So there's kind of a split due date, if that makes sense. It's trying to hold you honest, make sure you don't wait until the end. You will be responsible for cutting this file, making your appointment with the lab techs, getting your file cut, etc. Most of you have already done plenty of laser cutting, so I'm not particularly worried about this part. The 3D printing presents a little bit more of a challenge. We'll get to that. So it shouldn't be too hard. I will not take these early. I'll take them all on one day, and I'll try to do the grading all on that day. So the idea is that I don't have them for very long, because if I put all of these models in my office, the other people who share my office would murder me. So we're not going to have that happen. So anyway, that's the plan. So I brought a few examples so you can take a look at it. I will refer back to these examples as I start to make the file for today.
So this guy doesn't have any burn mark. All the white paper, all.
So when you do the laser cutting, cardboard's great because it's brown and it hides any of the little burned edges. White models tend to show a little bit, though if you want it, some of it's setting. So if your settings are off, you can end up burning and charring the edges too much. If you want to have it a little bit more pristine white, you can use one of those white magic erasers. Not the magic eraser that you clean with, or the white rubber erasers. And you can rub it along the edges and it'll clean up a lot of the char. It will still always look like a laser cut model. There's no way around that. You could gesso it, you could spray paint it white, something like that if you really wanted it to be pristine. For our purposes, we're using cardboard, so all is good. Okay, so a couple things as we move forward today. Once again, I'm going to start by going and getting a piece of terrain from SketchUp. So like I said, I'm starting all the way back at the beginning. If you already created your piece of terrain and you want to keep working with that same piece of terrain, that's fine. But I do today want you to re-import it and go through the process of building out the NURB surface. But if you want to change, if you hated your site, you can change it. Be aware that the really steep sites are hard to glue together. So if you pick something in Yosemite and it's like a cliff, I've seen it done and people can do it. Most of those people take their models home. So I don't have any examples of that. But something like this is a very reasonable topographic example. It's steep, it looks cool when you glue it together, but it's not so bad that you're never going to be able to put it together. So don't be thinking anything too much steeper than this. This is kind of our target. Okay, so I've gone ahead and I've opened SketchUp 2017, and I'm going to click on the Start Using SketchUp button, maybe. And there we go. I've opened up SketchUp. I don't need to do too much in SketchUp other than wait for it to finish saying it won't load the plugins correctly. There we go. Then I'll delete the little person. I don't need that person. We can get rid of him. And I'll go to File, Geolocation, Add Location. So once again, that's File, Geolocation, Add Location. And I'm going to pick my site. For the fun of it, I'm going to pick something in Hawaii. I'll go ahead and select region. Let me zoom out just a little bit. There we go, select region. I'm going to click on grab. And I don't know, in all honesty, if this is going to be a nice looking site or not. So we're going to find out. Yeah, Kristen.
On my computer, it says the SketchUp Pro license has, like, there's too many seats. It's not. And either way, it doesn't work on my computer.
Sweet. You got to love these kinds of things that happen, right? Probably means the other lab's using SketchUp, because of course we can't have lots of.
She's doing a SketchUp tutorial right now.
Okay, so just hang tight a little bit. We'll get that part sorted out. The what? Yeah, you can use the one from last class. That's fine, unless you didn't like your one from last class. You might have to zoom in a little bit further too. It depends. Okay, so let me go ahead and go to File, Geolocation, and I'm going to click on Show Terrain to see if I even like it. And that is a really terrible piece of terrain. Let me try to get another one. Actually, you know what? I think I have a piece of Hawaii terrain that I'll use from a previous semester. That'll be easier. So once you're done in the world of SketchUp, you're going to go to File and then Save As. And remember that if you're bringing it from the current SketchUp into Rhino, you have to save back a few generations. I think SketchUp 2013 works. Certainly, if you go back to SketchUp 8, it'll work. So you just want an older version of SketchUp, and you'll save that file. At that point, I'll go ahead and flip over into Rhino. I have a brand new Rhino file that's open. My units are in inches. It's important that your units are in inches because you're bringing in a SketchUp file which units are in inches. So we need to make sure that those match. I'll go ahead and go to File and then Import. So it's not Insert. We've been doing inserts. We're importing this file directly. So I'll go to File and then Import. And I'm going to pick that piece of terrain. Oh, it looks like I have Tahoe. Interesting. Well, we'll see what Tahoe looks like. I'll go ahead and say OK. And let me zoom out. All right, that'll work. And so when that file comes in, I get my piece of terrain. I also get the flat surface. Remember, SketchUp creates both. It creates the flat surface and the hill version as my triangulated mesh. Those are available via, I believe, layer 0 here. Yep, they're both on layer 0. I don't need the flat piece here, so we can go ahead and delete that altogether. I will work with this a bit more. So that's on layer 0. There shouldn't be anything on the Google Earth terrain layer or the Google Earth snapshot layer. I don't know why they create those layers. But I'll go ahead and delete both of those layers to clean up my layer stack a bit. There you go. And I'm going to rename layer 0, which is what the terrain is on, to be SketchUp Terrain. Just trying to maintain some clarity as I go through this. So from here, just like I did last class, I need to convert this triangulated mesh surface into a smooth NURBS surface to work with. So I'm going to use that contour command in 2 directions to create the contours going both directions and ultimately create my, my file. So I'm going to work with layer 2 here. I'm going to double click and I'm going to call it contour. We'll call it contour 1. I'm going to double click on the layer to make it active. And I'm going to contour this site as a series of parallel lines. So I'll go to Curve, Curve from Objects, Contour. Or I'll just type contour on the keyboard. It's going to ask me to select objects for contours. There's my object for the contours. I'll hit Enter. Contour base point will be down here in the corner. I do have vertex turned on so that I can snap to that corner point. There it is. Direction perpendicular to the contour planes. I'm going to go off along the y-axis right here. Remember, I'm not snapping to anything. I have my ortho turned on so that it's just infinitely going off in this direction. And then it's going to ask me for the distance between contours. And I'll do it, let me try 20, let's try 50 feet. Nope, little dense. So I'm going to do it at 100 feet. So I'll repeat the contour, curve, curve from objects, contour. There is my base point. Oops. We want to go off in this direction, not snapping to any objects. My distance between, I'll do 100 feet. There we go. Now I'm going to switch to layer 3. I'll rename that one to be contour 2. Just hit escape a couple times. Yeah. Okay, now I need to contour the same surface but going in the opposite direction. So I'll go back to my curve, curve from objects, contour. And I'm going to pick the mesh, not the individual lines. Remember, if I pick the lines, I'll get a bunch of points. You don't want that. So I have just the mesh selected here. I'll hit Enter. My base point is in the same point, but this time I'm going off in the x direction. It's actually the negative x direction, but it doesn't really matter. There it is. And my distance between is going to be the same at 100 feet. And I'll hit Enter. Now I have that grid. So I can go ahead and turn off the SketchUp terrain. And I have that grid that's ultimately going to create my curve network. So let me trim off the edges. So let me select a few of these curves. We'll do that one. Plus that one. That's that one and that one there. And I'm going to do a trim. So I'll go up to Edit and then Trim or type Trim. And I'm going to get rid of the extra little bits of lines here. All right, and that should eliminate any of those ragged edges around the outside, which is necessary to be able to do the curve network. I'll hit Enter when I'm done. And now I have my object ready to create that curve network or the network surface. Remember, this is always a good place to save. So before I move on, I'm going to save just in case it crashes when I do the curve network. So I'll go to File and then Save. And I'm going to save this into today's exercise, which is 212. And it's spring of 2018. There we go, just in case. Always a good idea. So now I need to go ahead and make that surface. So I will create a layer for that surface first. So I'll go ahead and double click on layer 6 here to change the name. And we'll call this, how about terrain? I'll double click on it to make it active. Now it's the current layer. And I can now go ahead and make my curve network. So I'll select the objects. There we go. And I'll go up to curve, or excuse me, surface, network, curve network, or I'd type in the command network surface. When I click on it, it's going to say, oh, you have more than 100 curves. Yes, yes. We want to continue. Yes. Oh, it was able to automatically detect. That's good. And we'll go ahead and say OK. Remember, this can take a couple minutes for it to generate the surface. And the resulting surface is going to be far too dense. So the next part of this is to rebuild that surface. So we'll let it finish up here.
Rhino doesn't let you go. More than 100, it doesn't let you go. Rhino 6.
Oh, Rhino 6 limits you to 100? It's probably a sign.
They don't even ask more than 100.
Nope, sorry. Yeah, I did receive confirmation, such that it is, that next semester, so when you guys get back from summer, if you're still here, we'll have Rhino 6 and we'll have V-Ray 3. So it's coming. And we'll also have the Creative Cloud version of Photoshop and all that stuff. So they are being updated, apparently. We finally got to that part. All right, so it was able to make it. Remember that when it does it, everything gets really slow. So you'll want to take your surface. It'll show up that bright yellow, and I'm going to rebuild that surface. And so in the rebuild dialog box here, I'm going to choose the to do 100 by 100. And I'll go ahead and say OK. And that then will rebuild the surface. I'm guessing that 100 by 100 is about the right level for what I'm trying to do. So I'll turn off Contour 1 and Contour 2. And I'm left with just that surface. If it's not smooth enough, I could rebuild it one more time if I wanted to. So essentially, this is the bulk of what we were doing last class. And we did a little bit more. We cut a few more contours. But this is about as far as we got last class. It's time now to start thinking about how do we make this surface into this model. And so we have to start thinking about scales, etc. So I'm going to walk you through this as we go forward. The first thing that you guys all have on your handout is a chart at the bottom of the page. And I made your life easier by giving you that chart. I'm going to pull it up online here, so bear with me for a second. All right, so there's that chart. So this is the same chart that you guys that you have on your sheet to work with. And it's going to give me a bunch of different information. So the first thing here is that I have a scale for my work. And so in our case, we're going to determine what the scale is based on the end model is going to be 11 by 17. That's what you're creating. But in something like 220, for example, when you're given a site, you might be told the final model needs to be at 1 to 200, or 1 to 500, or quarter inch equals a foot, or whatever. So sometimes it's given to you. In our case, we're going to determine it based on the size of the terrain. For most of you, your end model is going to be somewhere in the 1 to 500 to 1 to 200 range, in all likelihood, in terms of scales. But I have all the different scales that are here, should you end up needing these. So then we move over, and these units are all in feet. So I just want to make sure that I point that out. But if we come over here to what's called paper size, you see that I have listed 11 by 17. Your final model is going to be 11 by 17. So we need to know what size 11 by 17 is at one of these scales. So 11 inches at 1 to 500 is 12,000 feet. That's what it's telling you. 17 inches, at 1 to 500 scale is 5,500 feet. 17 inches at 1 to 500 scale is 8,500 feet, for example. The size that I'm going to do, I know it's always the chart is challenging, but once you get it figured out, it's not so bad. I'm going to give it a stab. My guess is that 1 to 500 is a little bit large for me, so I'm going to come down and either do 1 to 250 or 1 to 200. I'll do 1 to 200 as an example scale. So at 1 to 200, my 11 inches is going to be 2,200 feet, and my 17 inches is going to be 3,400 feet. So I'm going to go back into Rhino, and I'm going to draw a rectangle. It doesn't really matter where it is. And I'm going to say that rectangle should be at 2,200 feet, comma, 3,400 feet. And again, that's for 1 to 200 scale. And I'll go ahead and hit enter. There's my rectangle. That's the size of 11 by 17 at 1 to 200 scale. So if, for example, I move it over my project there, we'd see it a little bit better. So I'll do that one again, because I think I lost enough of you. Okay? So what I do, I've created this NURB surface. I'm going to go back to the chart right here, and I'm going to look up whatever size I feel is appropriate scale for my work. My guess is, for most of you, 1 to 200 is pretty good. Some of you, it might not be 1 to 200. Some of you might need to go up, so 1 to 250 or 1 to 500. Some of you may need to go down. It doesn't matter. You're all going to create the same size model. It'll end up fine. But my guess is that 1 to 200. So that's the example I'm going to use because I think it works for most of you. So if I follow the 1 to 200 over here into the 11 by 17 columns, I get 2,200 feet and 3,400 feet. So all I'm doing, you could do this if you were just doing math, right? If it's at 1 to 200 scale, you could do some math and you could figure out what 11 inches would be in actual feet. I'm just trying to help you out by giving you this information. So I know that it's 2,200 feet by 3,400 feet. So I'll come back to my Rhino file, and I'm going to draw a rectangle. So I'll start the rectangle, and I'll say at 2,200 feet, comma, 3,400 feet. If you did a different scale, you would type in different values here. So for my purposes, at 2,200 feet, comma, 3,400 feet, I'll hit enter, and I get this rectangle. That rectangle is 11 by 17 inches at 1 to 200 scale. So now I'm going to move this over my terrain, somewhere into my terrain. And I'm going to try to decide what part of the terrain do I like. I kind of like this little depression in here. That looks kind of interesting. that seems pretty good. You can play around with what part of the terrain you want. It's entirely up to you. We're just going to take a piece of this terrain. Once I've found the piece that I like, I'm going to go ahead and project that rectangle onto the surface. So instead of being a flat rectangle, it's going to follow the surface. So in the top view, I'll initiate the project command. So I'll go to curve from objects, project, or I'll type in project. It'll ask me to select the curves. There's my curve. I'll hit enter. Remember, I'm doing this in the top view. Select surfaces. There's my surface. I'll hit enter. And now as we look at this in the 3D view, you can see that it corresponds rather nicely to my surface. Make sense so far? So I use the project command to get that. From here, I can use this command, this line, to do a trim, and I can get rid of all the extra terrain that goes around the object. I could split it and put it on another layer and save it if I wanted to, but for our purposes, this is the model that I'm going to end up making, is just this piece of it. So now that I have the model figured out, there's my piece right there, it's now time to start thinking about how do I construct this model? How do I make this out of the cardboard? So then we're going to jump back. Let me hit enter to finish here. We're going to jump back to that chart that I had up. So the next thing that I need to know in this, remember I'm at 1 to 200 and I'm coming across here. The whole next set of columns says contour material thickness. So in order to understand how to make this model, I need to know how thick is the material that I'm going to make the model out of, the physical material, i.e. the cardboard. So you would go to the bookstore and you would buy your material and you'd get some calipers and you'd measure how thick it is. Or you take a ruler out and you measure how thick it is. It's really important to be accurate with this measurement. You really want to know. So what I'm going to suggest that you all do is buy the cardboard from the bookstore. Okay, it's easy to get to, certainly. You can walk over there. And because I've worked with it before, I know how thick it is, which is nice. So we don't actually have to measure it. This material looks like it's about 1/8 of an inch thick. It's actually a little bit more than that. It's 5/32 of an inch thick. So when I'm using this as my material, I have to keep coming over here to the column that says 5/32. So there it is. This number in the 5/32 at 1 to 200 scale, 31.25 feet, is the interval of the contours going vertically of this particular surface, i.e. every one of these little stripes that are cut out. So I'm going to jump back to my Rhino file. I'm going to contour this surface now. So I'll go to the curve from objects, contour. My base point, I'll pick this lower corner here. I'm not going in the X or the Y this time. I'm going straight up and down in the Z. So I'll zoom out in one of the front views or the right view so that I'm going straight up and down. There it is, not snapping to anything. And now when I type in the distance between contours, it needs to be this distance here. So I come across and I look at 5/32 of an inch. It's 31.25 feet. So I'll go back to Rhino and I'll type in 31.25 feet. It's important to put that foot mark in. And I'll hit enter. And so what it did is it sliced up that surface with a whole bunch of lines that represent all of the edges of the cardboard. Okay? So now I have those pieces identified. I really should put them on their own layer. So let me right click on layer 7 and say change object layer. And I'll rename layer 7 to be I don't know, topo lines, for lack of something else. So let me make the topo lines layer active. Let me turn the other stuff off. So now I'm looking at just my topo lines. If I did this right and and I look in the side view or the front view, they should be perfectly horizontal lines. That's what I'm looking for. If they're on an angle, they're not going to work. So here, I have these lines established. I'm ultimately going to be cutting those out. We'll get to that part of it next class. But for right now, I need to figure out how to make the sides. And if you look at one of the samples that I passed around, you see that the sides have all of these little steps on them. We're going to make those sides with all the little steps. And so we need to figure out how to do that. There's two different ways of doing it. There's one way that will appear really easy on the surface and simple. There's another way that will be a little bit more complicated. If you can learn the more complicated way, it will end up being simpler down the road. It just takes a little bit to learn it right now. So I'm going to go through both. I'm going to show you both methods today. The extent of what we're doing for exercise 212 is getting to the point where we do the steps. So you should today be doing some of the steps on some of the sides. That's kind of our goal. If you get through all of the steps on all of the sides, that's fantastic. You can stop there. If you get through most of the steps, that's good. If you get through a couple steps, it would be nice if you did a little bit more. But that's kind of what we're shooting for today. So I'm going to do the steps on one side. I'm going to go up this one side here. And I'll do the first method first, and then I'll do the second method, and I'll show you the difference. These, by the way, are written out. So if you get lost, if you go to the Digital Tools site, and you go to Tutorials, and you go to Physical Modeling 6.1, it walks through all the stuff that I'm doing. Okay? So if you get a little bit lost, you can go back there. There's also walkthroughs about how it went together. There's also me putting this whole thing together when this video is pretty funny because somebody gave me a glue bottle that explodes on me. So I get glue everywhere. It's kind of entertaining. Anyway, so I'm going to start with the first strategy on how we do this, and I'll do that by creating some points. But before I do that, let me create some sublayers or some layers to keep myself organized. I'm going to create a layer for side 1, and under side 1, I'll create a sublayer for S01 points. And we'll do a sublayer here for S01 steps. Just trying to keep my brain a little bit organized here. So I'll make the points layer active. And I'll come over and I'm going to choose to create a point. Now, if I left click, I'll get a single point, in which case I would have to put the point, right click to repeat the command, and put the point. If, however, on this point button, I right click, it will let me create multiple points, in which case I can just work my way up. What I'm going to do is I'm going to put a point on the end of every one of these lines. So I'll stick a point as I go up on the ends of all of these lines. You want to make sure that you're snapping to the end each time so that you are, in fact, on the end. And we'll finish with the last point. So I've gone all the way up with my points, one on each one. And now I'm going to rotate all of those points flat so that I can draw the steps a little bit easier. So I'll select all of these points. And I'll use the Rotate 3D. Oops, looks like I missed a point right there. Let me add a point. There we go. And I'll select them all again. And I'll use Rotate 3D. So I'll go back up under Transform, Rotate 3D. I'll pick the first point right there. I'll go just out along the x-axis, wherever it takes me. I'll go straight up and down. And I'll fold those points down flat. So there they are, folded down flat. Once that's done, I'll move my layer, my active layer, to be the steps layer. And basically, I'll start with the polyline tool. I'll start at the first point. I'll move over and snap. And it's a matter of basically you hover over one point, you pull back, and you get the little perpendicular, and you can make your next snap. So I'll move over. and I'll start drawing my steps. So I hover, I move over, I get that nice little object track. There it is. And I work my way up. And obviously, as the terrain gets a little bit steeper, the points get a little bit tighter. Almost there. And there we go. I finish. It doesn't matter when you're working on your points if you go up and over or over and then up as you do the steps. One will just be higher than the other. It doesn't make any difference. We'll correct that problem a little bit later on. So when I'm all done, I'll select that stepping line that I created plus all the points. So let me just drag a box around all of it. I'll do rotate 3D again. So I'll go back to transform, rotate 3D. Starting on the same point, I'll go off in space. I'll go flat and fold it back up so it's along the edge. If I did it right, it should match up and have all of its little steps running up the side. So, to me, that way seems easier initially to do that rotation and then rotate it back. The alternative to that is to use something called a seaplane. And if you guys have worked in AutoCAD before, this is essentially like UCS coordinates in AutoCAD. In Rhino, they call it a seaplane. What it is it is the drawing plane that you're currently drawing in. And so by default, when we're in the perspective view, we're in the top seaplane. And you can see if I turn on my grid, that's probably on, right there it is. It looks like your normal XY, it's flat. You guys have seen this. I'm going to enlarge that grid for demonstration purposes. You don't have to do it if you don't want to. Let me go ahead and on Grid Snap here, I'm going to right click and say Settings, and that'll take me into the grid settings. I'm just going to add another 0 to the grid line count. And I'll say minor grid lines every 12 inches. That works. And I'll go ahead and say OK. And now I have a much larger grid. The grid doesn't do anything for you other than it helps you visualize where the seaplane is. So right now the grid is flat, the seaplane is flat. It's in something called World Top, which is the default, when in doubt, go back to World Top. I would like to change that so that I could actually draw along the side of one of these, basically the steps along one of the sides. So I'm going to go to the little triangle next to where it says perspective, and I'm going to go to Set Seaplane, and I'm going to choose 3 points. I like 3 points the best because it's really easy to think about origin, x-axis, y-axis. So I'll do 3 points, and it's going to say, where's the origin going to be? I'll come up here and pick this line. Sure, that works. I'll click. Then it's going to say, what is the direction of the x-axis? So I want the x-axis going off, just off in space here. My ortho is on, so it's snapping nicely. There it is. Now it's asking for my orientation, which essentially means, do I want it to be going sideways or do I want it to be going up and down? So I'll move into the front or the right side view, and I'll go straight up and down, like that. And you see that in the perspective view, my grid is no longer flat on the ground, but is instead even with the edge of my drawing, even with the edge of my steps. Anything that I were to draw, if I drew it off in space, would end up on that plane instead of being flat. So what this allows me to do is, without creating any points or anything special, I can start at the lowest most line, which is right here, and I can start working my steps directly in the side view, snapping to all the ends. So there's no rotations necessary. it will let me just draw directly on the side. So for me, once you understand the concept of a seaplane and the fact that you can change the drawing plane into something more convenient, changing this is far more simple than creating all the points and doing a rotate 3D. This is actually something I do on a very frequent basis when modeling in Rhino, depending on what I'm trying to draw. For example, you remember back when we were creating the house at the beginning of class and we did the floor plan, then we had to do the elevations. You could set the seaplane to be along one of the faces of the walls and draw the windows right on the wall without having to do any rotations or projections. So it can be very, very useful, but it takes some practice. So I'm going to end right here for now, and we're going to deal with how the corners come together a little bit later on. So when I'm done with that wall, or that side, I'm going to set the seaplane back to world top, which remember is that default setting. So I'll go back to my triangle, and I'll go to set seaplane, and I'll go to world top. And that sets it back to being flat. I'll go back in, and I'll reset the seaplane for the front, and I'll draw it again. So once again, I'll go to the triangle, I'll go to set seaplane, and I'll go to my 3 points. I'm going to start with that first point. There it is. We're going to go off in this direction. There's my x-axis. I need my y-axis to go straight up and down. And there it is in line with the front. Now I can go through and I can keep drawing. So again, I'm ignoring the corner, and I'm starting from here. And I'm going to work my way down. Now I wanted to show you this one because you're going to run into a few of these. So here, I've come across, I've done my steps, and I get to that point. Wait, do I go straight across again? What do I do? Well, in this scenario, this contour right here is at that level. This contour is at that level. So the next contour would actually be down. So I know what the value is. Remember, it's 31.25 feet. I got it off my chart. So I can actually type in 31.25 feet. I'll go down, over, and then I'll start back up again. So now I get to, I'm coming up to the top of a little hill. So in this case, I come, wait, there's no step. Well, that's true because it's at the top. This contour line here, if it were continuing on, would match up to that contour line. So I'll go straight across and then go back down. When I get to this one, I would go down 31.25 feet. I would go over, and then I continue back up. Then I'd come over, and now I have to start going down. So the truth of this, though, is that if I were laser cutting this with that little piece, that would just burn off into nothing because it's just so small. It's not like I'd be able to glue that together. So you can, if you want, get rid of those kinds of pieces. That piece is too small. I could get rid of it, and then this step would go straight across rather than having that step in it. You'll find a few of those along the way. There was this piece right here at the end of what I was drawing. That probably needs to go away too. So feel free to have some edits like that as you start to work your way through. So what I want you to do today is I want you to try to get to the point where you're doing these steps on the sides. If you don't feel comfortable with seaplanes and you want to do the rotation, there's nothing wrong with that. It just takes a little bit longer and there's a few extra steps. If you want to work with the seaplanes, give that a shot and see. I think long term, learning the seaplanes is a good move. I think it's going to help you in your modeling down the road. So I would encourage you to try it out. Are there any questions? No? So like I said, try to get the steps done. Ignore the corners. We'll deal with the corners next class. Try to do your best when it comes to the ups and downs if your terrain does this. If you make a few mistakes, it's not a big deal. Before you actually do the final laser cut, I will look at every person's file and make sure that your corners and that your ups and downs match. So we'll get there.
The only question I have is, how do you take your imported file and get it to without the mesh?
I'll come and help you. Are there any other questions? No? Okay, I'll turn you loose.